So let's review limits from Math 250, some of the basics that you should know before we get to some of the advanced limit taking. First up, anytime somebody gives me a limit, you know what I do first thing? First thing, no questions asked, direct substitution. That's what you're supposed to do the minute somebody gives you a limit. Because after you do the direct sub, you may be done. Like that might be the answer. Here's an example, people. We're going to take the limit as x approaches 0 of sine x divided by e to the x. Well, you're just going to use direct sub. You're going to substitute 0 for x. So what's sine of 0 divided by e to the 0? Well, sine of 0 is 0 and e to the 0 is 1. What does 0 divided by 1 equal? Does it equal anything?
0.
It's 0. So final answer is the limit exists, and the answer is 0 for this problem. Now, if you get some weird thing that, you know, isn't an actual finite value, then you need to worry. But if you do get a value that's legit, and 0 is a perfectly legitimate limit, this is the same as the y coordinate that gets hit. What do I mean? Well, if you went and graphed y equals sine of x divided by e to the x, and you looked at the graph when x is 0, the y coordinate at that moment would be a 0 also. Okay, so the point 0, 0 is on the graph. Okay, and you know, and if you don't believe me, you know, if I go to, let's just graph sine of x divided by e to the x because it's kind of fun. Oops, that is not what I wanted. Wrong-o. Come on, guy. What are you doing? No, that's still wrong. Well, let's see how I can get this to work for myself. I got to trick it into doing what I want. Okay, here we go. Woo! That's a cool looking graph. I like it. So would you guys agree that here at x equals 0, the y coordinate getting hit is also 0? Hello?
Yes.
Okay. Now notice this is a pretty weird looking graph because out here it's pretty nuts. It's like going up and down, oscillating quite a bit, and then it kind of gets calm here. And it doesn't go down to 0. It looks like it's going to approach 0 asymptotically or something, or is it? I don't know. I think it is approaching asymptotically. Cool. It's an interesting looking graph. Now let's look at some limit facts that you should have learned in Math 250. If you didn't, don't worry. I'm going to make sure you get them now. We can't move forward unless you memorize these. Suppose you got an answer after you did direct sub for a limit problem, and it was 0 divided by a constant, where c is some constant like 2, okay? So we just did a problem like that. Like, what did we get 0 over 1 was equal to? Quick.
0.
0, thank you. Okay, we're done with number 1. Congratulations, that's one of your limit facts. Know it. What if you got something like infinity divided by a number, like infinity divided by 2? What would that end up being?
Infinity.
Yeah, that's still a big number. It's still going to be infinity. Okay, forget it. Now, the next two have to do with the graph of y equals ln x. And if you remember what the graph of y equals ln x looks like, then that'll be helpful for you to get these two limit facts in hand. So what is ln of infinity? Or what happens when you take the limit of ln x as x gets very, very large? So here's the x-axis. X is getting really, really large. What is y doing? What y coordinate is going to get hit eventually?
Infinity.
Yes. So please memorize this, because if you don't, the rest of the semester is going to be very painful for you. By the way, I do want to say that when we get into the sequences and series module after spring break, if you get your limit facts, it'll be much more fun for you, because we're going to do basically the study of infinity. And we're going to be doing a lot of limits at infinity, especially. So if you understand a lot of these limit facts on this page, it's going to be really great. If not, okay. Now what about ln of 0? Do not say 1. because that's wrong. ln of 1 is equal to 0, but ln of 0 is equal to what? Now here's how you're going to do it. So here's the x-axis here. If x gets really, really, really close to 0 here, what's the graph doing? I'm giving you a hint here.
Negative infinity?
Yes, it's going down, down, down to negative infinity. So ln of 0 is negative infinity because the graph is just going down, down, down. And we're doing 0, approaching 0 from the right with that little superscript plus sign, because you can't approach from the left because there is no graph over here. There's no ln x graph, so it would make no sense to have ln of 0 approaching from the left-hand side. Okay, number 5, what's 1 divided by a very, very, very large number? Infinity could be your favorite large number, like 5 zillion. It's essentially equal to what? When you have a fraction with a super large denominator.
0.
Yeah, 1 over infinity is equal to 0. Please memorize these. I'm begging you. If you don't, the rest of the semester will not be fun for you. Okay, numbers 6 and 7 are helpful if you know what the graph of e to the x looks like. So if you don't have e to the x memorized, you should. But e to the x is a very nice graph, and it has this shape to it, okay? So what is e to the negative infinity? What happens when you have x here on the x-axis go very negative? What y coordinate gets hit here?
0.
0. Yeah, it approaches the x-axis. Never hits it, but gets awfully close. That's an asymptote. Now, what about e to the positive infinity? So e to the x, what happens is x gets very, very large and goes to positive infinity. What y coordinate gets hit? I'm giving you a hint here.
Infinity.
Yeah, positive infinity. Yeah. So e to the negative infinity is 0, but e to the positive infinity blows up and goes to infinity. Now, for other bases like 2 to the negative infinity or 2 to the positive infinity, it has similar limits as long as the base is a number that's greater than 1. The base is less than 1. It has 2 different answers depending on what your issue is. Do not say DNE does not exist. I know that your Calculus 1 teacher may have been okay with you saying, hey, you're not allowed to divide by 0, you know? So if you ever get that, the answer is DNE. In this class, no. This class, I won't accept it. Why not? You'll see in a minute. So I'll either accept infinity or negative infinity, depending on what kind of 1 over 0 you're looking at. Although typically it's kind of okay if you just say infinity. So why is that? So if you look at the graph of y equals 1 over x, say, and I'll graph it for you. So if you look at the graph of y equals 1 over x, when you approach 0 from the right here, it blows up, goes to positive infinity. On the other hand, 1 over 0, when x comes in from the left, it goes down, down, down. It goes down to negative infinity. So which one is it? Well, it kind of depends. But what about if you had 1 over x squared? That's a different thing, because whether you approach 0 from the right-hand side or the left-hand side, it's going up, 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 up. Do you see that? And so the y coordinate that is getting hit for 1 over 0 is essentially positive infinity, regardless of your left or right-hand side limit. Does everybody see the difference here? This is a subtlety, but a nice one. Okay, number 9. What if somebody said, oh, my erase tool isn't working. Let's try this. What's cosine of infinity? Or even sine of infinity? I claim both of them are going to give the same answer. If you look at either the graph of sine or cosine, you know that as x goes to infinity, it never settles down. It just goes back and forth between a high of 1 and a low of -1. So the answer is D and E, does not exist because it oscillates. I thought you said it's not okay to put D and E. I never said that. You didn't hear me. I said for the 1 over 0 or 1 over infinity, you don't put D and E. But for cos infinity or sine infinity, those limits just boing, back and forth between 1 and -1. Okay, however, what if somebody said take a limit as x goes to infinity and they took your cosine x and divided it by something else? Now, if you use direct sub, you get cos infinity over e to the infinity. But e to the infinity is infinity from our previous limit fact here, number 7. So what of it? Well, when you are looking at plus or minus 1 over infinity, look at fact number 5. What does fact number 5 say that limit is going to be?
0.
0. So if you have cosine or sine in your numerator and the denominator is blowing up, there will be a limit. It won't be D and E. So similarly, like sine x over x, where x goes to infinity, you've got your sine of infinity, which is still oscillating between plus or minus 1, but the denominator is blowing out. So it's just going to drag that whole fraction down to 0. And we're done with that. Now, number 11 requires knowledge of the arctan function and his graph. So if you recall, when I was showing you inverse trig stuff during week 1 of this class, arctan was one of my favorite graphs, especially when it comes to limits. Really? Yeah, because it's got limits both in the positive and negative infinity direction. It's very cool. So here's the graph. It's got a horizontal, 2 horizontal asymptotes. Check it out, baby. This is a cool graph. So when x gets very, very large, the graph gets closer and closer to this upper dotted line, which has the equation y equals pi halves. When x gets very, very negative, the graph approaches this downhill dotted line, this dotted line down here, which has the equation y equals negative pi halves. So arctan is really cool, and arctan of infinity and arctan of negative infinity. Memorize these because I'm really into those. Like, do you think they'll be on a quiz in the future? Oh, yeah. Yeah, for reals. Okay, I'm trying to find out if my internet is up yet. Still not definitive. We'll find out. Oh, man. Okay, so there is 1 through 11, but we have some more. So let's do some more right here. Okay, what's 0 over infinity? It's actually the same as number 1. It's going to still give you a 0. What about number 13, infinity over 0? It'll be the same as number 2. It'll just be a big number, infinity. What about 0 to the infinity? It's still 0. What about 0 to the negative infinity? Ooh, you better be careful because that's 1 over 0 to the positive infinity, which is 1 over 0. And then you have to worry about, well, is it going to be plus or minus infinity? I'll just say infinity. We'll just go with the positive. Now, what about a big number, infinity, added to another very big number, infinity? Well, it'll be infinity. Nice. What about negative infinity minus infinity? Well, that'll be still a very negative number, the worst negative number you could get, negative infinity. Okay, so there's some more limit facts for you. I hope this was helpful. You'll see that it will be because you'll probably refer to this page as you do some of the homeworks as well as quizzes and exams. So let's actually do some examples now with L'Hopital's rule after we go over what that is. Cool. So let's talk about indeterminate form. An indeterminate form is something that you can't figure out what it is. Like, don't even say you know what it is. Like, oh yeah, that's 0. No, you don't. It's like meaningless garbage. So here's an indeterminate form, 0 over 0. Like if you get that, don't go, oh yeah, that's equal to 0, because I'm just going to take away all your credit. Now, the final answer might end up being 0, but you have no idea. Infinity over infinity is considered indeterminate. No idea what that is. Negative infinity over positive infinity. Positive infinity over negative infinity. Negative infinity over negative infinity. Those are all indeterminate forms. There's more. In fact, infinity minus infinity is considered indeterminate. Well, you just told us what that is. No, I didn't. Check it out. In the limit facts, I said infinity plus infinity. You can definitely say that's infinity. And negative infinity minus infinity is negative infinity. But infinity minus infinity, nobody knows what that is. You may have to do some work. So don't go, I know what that is. Another one that's considered a hot mess is 0 times infinity, that's indeterminate. 0 to the 0, that's indeterminate. 1 to the infinity and infinity to the 0. These are all indeterminate. Do not say that this is equal to 1 or to 0, either one. Don't say 1 to the infinity equals 1. Well, I thought 1 to 1 to 100 is equal to 1. That's true. But 1 raised to the infinity power, you have no idea. That's indeterminate. Okay? So now let's do the L'Hopital's rule. This is cool. This is one of my favorite theorems in this class. So here's how you're going to write it in. Let f and g be differentiable functions. Write this down. On some interval, a to b, containing another number, c, except possibly it's c itself. It might not be differentiable right there at that moment, but that won't matter. Okay, now assume that g prime never goes to 0, otherwise you'll be in trouble. For all x on that's an epsilon, that just means belonging to that interval, except again, possibly at c, because that's like the weird guy. Okay, now what? Here's what the cool L'Hopital's rule allows you to do. Suppose you took the limit of this quotient, f of x divided by g of x, as x approaches c. And you got one of these 5 indeterminate forms, one of those 5. So you get 0 over 0 or plus or minus infinity divided by plus or minus infinity. One of these guys, these are indeterminates. If you get any of those, then here's what you're allowed to say and do. You're allowed to retake the limit as x approaches c of a new fraction. The new fraction is the derivative of the numerator divided by the derivative of the denominator, provided the limit exists, of course. Now, be careful because I'm not doing the quotient rule here. Do not do the quotient rule. This is not the quotient rule. This is separately taking the derivative of the numerator and separately taking the derivative of the denominator, not applying the quotient rule. That's a totally different creature. That's a common student error too. Oh yeah, I gotta do the quotient rule. I'm like, what are you doing? No, L'Hopital's does not tell you to do that. So what are the two cautions? If you take the limit as x approaches c of this weird fraction, f of x over g of x, and you get 0 over infinity, you don't need L'Hopital's or infinity over 0. No need for L'Hopital's. Why not? Go check your limit facts on the previous page. What's 0 over infinity?
Zero.
Thank you. How about infinity over 0?
Infinity.
So you don't need L'Hopital. So do not use L'Hopitals when it's not applicable. If you do that, I will take away all your credit, even if you got lucky and you get the right answer, because that means you don't understand L'Hopitals. So L'Hopitals is specifically allowed to be used if you get 0 over 0 or any of these plus or minus infinity type quotients. But if you get a mixture of a 0 and an infinity, don't bother. Now the other one, and I just set it up here, but I'm going to say it again, f prime of x divided by g prime of x is not equivalent to f over g prime. This right here involves the quotient rule, and we're not about doing the quotient rule in L'Hopital. So don't make the mistake of doing a quotient rule when you're applying L'Hopitals. You're just separately taking the derivative of the numerator and dividing that by separately taking the derivative of the denominator. It's much easier than the quotient rule, actually. Okay, now we're going to do some examples of L'Hopitals, which is really cool. If you've never seen this, and this is your first introduction in L'Hopitals, you're going to love it, because these are limits that they couldn't give you in Calculus 1 because they were too hard. Or if they did give them to you, they made you figure it out by graphing or making a table and evaluating it, you know, getting closer and closer and closer when you fill out the table. And it was really annoying and it was really tedious. It was like, ah! And here you don't have to make any tables, nothing like that. It's great. Okay. Starting off with this limit, you still have to do direct sub as your first step. If you fail to do this as your first step, I will take away a lot of points. Like, don't go, oh, everything's L'Hopitals now. No, 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 no. You have to prove to me that L'Hopitals is even legit to use. And the way you prove it to me is after you get your first direct sub happening, you get one of these indeterminate forms, 0 over 0, or plus or minus infinity over plus or minus infinity. Okay, so here we go. We do direct sub first. And I get e to the 0 minus 1 over 0, because the limit is as x approaches 0. Oh, but wait a minute. E to the 0 is a nice number. It's equal to what?
One.
So this numerator is 1 minus 1 over 0. Hey, but that's 0 over 0. That means L'Hopitals applies. So I'm going to put LH for short. That's going to always stand for L'Hopitals. So then what? You're still going to take a limit as x approaches 0. So I still want you to write down lim x approaching 0. And you're going to differentiate the numerator. So the derivative of e to the 2x minus 1 is 2e to the 2x. And you're going to divide that by the derivative of the denominator, which is pretty easy because the derivative of x is
1.
And now use direct sub, and hopefully it all works out. And there's your final answer. So the limit exists and it's 2. Pretty cool, huh? So I'm going to do letter B now. This is a little bit harder limit because we're taking a limit at infinity. So it's kind of weird to use direct sub, but you still use it. I want to see it. What is ln of infinity divided by infinity? And you're going to need one of your limit facts on the previous page. What did I say that ln of infinity was equal to? Go check it.
Infinity.
Infinity. Yeah, so this is infinity over infinity, but that's indeterminate. And that's one of the indeterminates that you're allowed to use L'Hopitals for. So you're good to go. Use L'Hopitals. So LH, L'Hopitals applies. So what are you going to do? You're going to retake the limit. So write it down. And then you're going to differentiate the numerator. Well, the derivative of ln of x is 1 over x. And you'll divide that by the derivative of the denominator, which is just 1. Okay, not fine. And then do direct sub again. And so, well, what do you mean? You're just going to plug in infinity in place of x again. But 1 over infinity actually has a nice answer. Go check your limit facts. What did I say 1 over infinity equals?
0.
And you're done. And that is the answer. Questions? Okay, let's keep going. So if you took Math 250 and they did not cover L'Hopital's, one of the problems you probably got was something hellacious like this, because when I teach Math 250, I give this problem. And I don't teach L'Hopital's when I do Calc 1. Ooh. So let's first do direct sub. So when you do direct sub, so x is approaching 0, so we're going to substitute 0 in place of x. So what do you get? I get 0 over 0. So what does that mean? Apply L'Hopital's. Now, in Calc 1, I don't allow my students to use L'Hopital's. Otherwise, I give them 0 credit for that problem. So how did they work on this one? I don't want to do the whole thing, but I'll just allude to it. So if you're tutoring somebody, a friend in Calc 1, say, and they're not allowed to use L'Hopital's, don't go, oh, I forgot. You multiply by a special version of 1. And the special version of 1 involves rationalizing the numerator using the radical conjugate. So it's a pretty disgusting version of a special version of 1. In this case, it's going to be the square root of 25 minus x squared plus 5 divided by the square root of 25 minus x squared plus 5. That's the special version of 1. I'm just going to put et cetera, et cetera. And then after you do some algebra and multiplying the two fractions together and some cleanup, it actually has a nice answer. The same answer we're about to get, but not as much work. So we're going to apply L'Hopital. So what does that mean? We're still going to take the limit as x goes to 0. We're going to differentiate the numerator. Now, that square root of 25 minus x squared, I'm going to rewrite it as 25 minus x squared to the half, because I'm going to use the power rule to take the derivative. So the derivative will be a half. The quantity 25 minus x squared to the negative a half, and we got to use the chain rule, times the derivative of 25 minus x squared, which is negative 2x. And then, of course, the derivative of minus 5 is 0, divided by the derivative of the denominator. Well, the derivative of the denominator, x, is just 1. Now, before I do direct sub, I am going to rewrite this without negative exponents and clean it up a little bit, because you'll thank me later that I asked you to do this. So these 2's reduce, and so after cleaning this up, and I'll put the radical back in, now we're just working with this thing. Well, now use direct sub. And you get minus 0 all over the square root of 25 minus 0 squared, but that's 0 all over square root of 25, which is 0 over 5, which is what?
0.
0, and that's the final answer. And we're done with letter C. Any questions so far? Okay, sometimes you run into problems that Math 250 students do, and they're not allowed to use L'Hopital's. If you use direct sub here, you're going to get sine of 0 all over 4 times 0, which is 0 over 0. So I can apply L'Hopital's. So let me tell you a quick story about L'Hopital. You may not know this. Do you notice how the word L'Hopital kind of looks like the word hospital?
Yeah.
It does. So back in the day when L'Hopital was running around, they didn't have hospitals. You may think, oh, well, everybody had hospitals, you know, way back. No, they did not have hospitals all the time. You know, like 150, 200 years ago, there was no such thing as a hospital. If people got sick or hurt, they usually stayed at home. and the doctor would come to the house and work on you or operate on you at your house, which could get kind of messy. And so L'Hopital was a man who kind of had a vision, and he thought, you know, these poor doctors are running all over the countryside trying to visit people's houses that are sometimes pretty far away and spending a lot of time traveling and wasting time. Wouldn't it be better if we had one big old building and we put all the sick, hurt people in one area, and then the doctors wouldn't have to go all over the place? And that was brilliant. And you may think, well, that's obvious, but it wasn't back then. And even now, hospitals suck out a lot of money and energy in order to keep going. So, I mean, they're not exactly the most efficient necessarily. And they do a lot of evil things to keep the money coming. But that's a story for another time. But L'Hopital Hospital, that's why hospital is named after him. I don't make this stuff up, I just report it. Go check Wikipedia if you don't believe me. Okay, back to our usual regular scheduled programming. So since we're allowed to use L'Hopitals here, we're going to still take the limit as x goes to 0, but we're going to take the derivative of the numerator. Derivative of sine 6x is 6 cosine 6x using the chain rule. Divide that by the derivative of 4x. That's just a 4. You can reduce a little bit right now. Okay, fine. And then use direct sub. And if I substitute 0 here, cosine of 0 is really just a 1. So final answer is 3/2. But when you do this in Math 250, you're given this theorem that says the limit as theta goes to 0 of sine theta over theta is equal to 1. You're only allowed to use that theorem. And then you have to make this quotient look like sine theta over theta with some algebra. And it'll still end up being 3/2, but I'm just saying. Okay. So now let's do some limits involving arctan, because you know I love arctan. It's one of my favorite functions. So I'm going to use direct sub first, like this. And it turns out arctan of 0 is 0. So you get 0 over 0, which is indeterminate. Now what? Use L'Hopitals. So you're still going to take a limit as x goes to 0, and you're going to take the derivative of the numerator. Oh, that's easy. Derivative of x, 1. And you're going to divide that by the derivative of the denominator. Uh-oh. How do you take a derivative of arctan 2x? So let me just remind you that ddx of arctan of u, this is from like, 6-7 weeks ago, is u prime all over 1 plus u squared. Remember this? You need that to do what we're about to do. So the derivative of arctan 2x is u prime. U is 2x. So derivative of u prime is 2 divided by 1 plus the u, which for us is 2x squared. Now, this is like a 1 divided by a fraction. I'm going to rewrite it before I do anything. The numerator, and then we can take the reciprocal of the denominator. It looks a little nicer. And now use direct sub. So you're going to go 1 plus 4 times 0 squared all over 2. I get 1/2. And that's the answer. You're done. That's the limit. L'Hopitals. Saves the day. And now another limit at infinity. And now you're going to use 2 of the limit facts that I gave to you. So you're going to use direct subs. You're going to go e to the negative infinity, and you're going to divide that by arctan infinity, and then go check your limit facts. What did I say e to the negative infinity is equal to?
0.
And what did I say arctan of infinity is equal to? Not 0, but what?
Minus pi over 2.
This is positive infinity.
Yeah, not bad.
Arctan of positive infinity. So you're going to have pi half. And so the final answer is?
0.
And we're done. Okay, I'm going to finish out this page and then I'll set you free, okay? So what about when you are using L'Hopital's and it ends up being indeterminate again? What do? You apply L'Hopital's again. What happens if you get another one of those indeterminate? Do it again. Do it again and again and again until you're done. So what am I saying? You may need to use L'Hopital's more than once. So check it out. So here we have limit as x goes to negative infinity. And so you have x squared over e to the minus infinity. Be careful here because I am trying to trick you. You're going to substitute negative infinity. But negative infinity squared is going to be a positive. So you will get a positive infinity. And this is e to the positive infinity. Check your limit facts. What's e to the positive infinity go to?
Infinity.
Yeah. So this is indeterminate and you're allowed to use L'Hopital's. Okay, fine. So you're still going to take a limit as x goes to negative infinity. You're going to take the derivative of the numerator. The derivative of x squared is 2x. And you're going to divide that by the derivative of the denominator, which is negative e to the negative x. And now use direct sub. So 2 times the negative infinity is negative infinity. And here we have negative e to the positive infinity, which is going to be negative infinity. Guess what? L'Hopital's again. Oh man, how many times do we need to use it? As many times as it takes. So this limit here, you're going to rewrite it. Limit as x goes to negative infinity. Keep going. Use L'Hopital's again. So what's the derivative of 2x? 2. Divide that by the derivative of minus e to the negative x. That's going to be e to the negative x. And then use direct sub again. Okay, 2 divided by e to the minus infinity. That's 2 over e to the infinity. That's 2 over infinity. What's 2 over infinity go to? Check your limit facts.
0.
And you're done. And that is the answer. Letter H, answer is 0. Or excuse me, G. Haven't done letter H yet. Okay. So letter H, you're going to need repeated L'Hopital's like 3 times. When you first plug in your infinity, you get e to the infinity over infinity cubed. But that's infinity over infinity. Go use L'Hopital's. Okay. Take the limit again. I'd take the derivative of the numerator, divide that by the derivative of the denominator. And these 3's can cancel. And then do direct sub. But I still get infinity over infinity. Ugh. Use L'Hopital's again. So I get 3e to the 3x over 2x. Oh man, now what? Well, you're going to use direct sub again. That's infinity. And then divided by, oh, I'm cutting out again. 2 times infinity is infinity. Do L'Hopital's again. Really? Yeah. So take limit as x goes to infinity of 9e to the 3x all over 2. And now do direct sub. But I get infinity over 2, which is infinity. And so it is possible for your limit to just blow out and go to infinity. And that's what happens here. So the answer to letter H is infinity. Okay, letter I, you're approaching 3/2. If you do substitute 3/2, you'll get 0 over 0. In your Calc 1 class, since you weren't allowed to use L'Hopital's, or I don't allow it, I would say, well, factor and reduce and then hope it could work out. And it turns out this does factor, so you could reduce. And then when you use direct sub on that, you substitute in your 3/2 here like this. And then you get a nice answer. You get like 5/2 over 17/2, which is 5/17. But let's say you didn't know to factor. You would just use repeated L'Hopital's until you ended up getting this answer, and you will. Okay. All right. I think I'm going to quit there, and I'll pick up the limits lecture next time on J and K here. So I'm done for today. Congratulations. That's it. If you have any quick questions,